So moving on to day 3 of chapter 2. So we got unit 2A, day 3 today. Today we're going to spend the first little bit reviewing. I'm going to give you one that's in vertex form and one in standard form. Yesterday and Monday, make sure that we've got those down. And then we're going to look at some word problems and then writing equations of parabolas if you're given just a couple different things. So a mixed bag of things today, some old, some new. Okay, so let's start out with a review from yesterday. We're going to identify the form and find the following information. Should be an equal sign in there. This should be y equals negative x squared plus 6x plus 2. We'll work on it together. No sense in you doing it yourselves. So what form is it? Is it in standard form or is it in vertex form? Can you easily find the vertex from that one or not without using a formula? Or that one's easier to find the vertex. Which one's easier to find the vertex? This one. So that's vertex form, so that makes this standard form. So this is standard form. This is like what we looked at yesterday. So when we had something in standard form, we identify the A's, B's, and C's right away. So the A value here is negative 1, B is 6, and C is 2. Direction of opening was found by looking at your A value. If the A value is negative, did it go up or down? Down. Says A is negative 1, this is going to go down. Next thing we had to find was the line of symmetry. Remember, we found the line of symmetry by using the formula x is equal to negative b over 2a. So our b value is 6. So that's negative 6 over 2 times negative 1, which is negative 6 over negative 2, which is 3. So our line of symmetry is x is equal to 3. And the only way we can do this if it's in standard form is by using this formula. Next part says find the vertex. Remember when we found the vertex, we knew the x value had to be 3. It has to be on the line of symmetry, and that line of symmetry was right here. How did we go about finding the y value? Very good. We plugged that 3 value into the original equation. So that's negative 3 squared plus 6 times 3 plus 2. So that's negative 9 plus 18 plus 2, which is 11. So our vertex is at 311, which is way up there somewhere. So that's the point 311. Maximum or minimum? This graph goes down, so it goes like that. So it is a maximum. What's the maximum value? 11. Remember, the maximum value is the y value at the vertex. Domain's always the same. Negative infinity to infinity. The range, what's the lowest? Negative infinity. What's the highest? 11. Now it says more points. Because it's in standard form, we can find the y-intercept. Remember, the y-intercept is the point 0c. So that would be 0, 2. So my graph goes like this. through 0, 2. And then we can find one more point. This goes from 0, 2 to 3, 11. So my x goes from 0 to 3. So that has a distance of 3. So if I go 3 more over, I've got another point. And that's the point 6, 2. And there's my graph in standard form. Finding all of those things. That's what we did yesterday. Monday, we looked at ones that were in this form. Y is equal to, and then x minus 1 squared in parentheses plus 3. So if we identify the form, this is vertex form. Direction of opening, up or down? Up. We look at this value that's out in front of there. There's nothing there, so that means it's going to go up. If there was a negative there, it would go down. It goes up. When it's in this form, find the vertex first. What's the vertex? Opposite of what you see and what you see. So 1, 3. That makes the line of symmetry. X is equal to, what's my x value at the vertex? 1. So x is equal to 1. So there's my line of symmetry. Now we said it goes up. So it goes like this. So is it a max or a min? Minimum. What's my y value at the vertex? 3. Domain always the same. Negative infinity to infinity. The range, what's the lowest point? 3. What's the highest point? Infinity. Very good. Then we got to find more points. So we're just going to use 0 for our x value. So if my x value is 0, we're going to plug it in. That's 0 minus 1 squared plus 3. So negative 1 squared is 1. 1 plus 3 is 4. So we have the point 0, 4. That's 1 unit away. Another unit away is 2, 4. So there's your more points. And you're done. So those were 2 review questions from the last couple of days. One in standard form, one in vertex form. Any questions with either of those? Bless you. Twice. 3 times. Okay, so the next question is just asking you to find the maximum, minimum or maximum. So it says state whether each function has a minimum or maximum, and then find it. All right, so you're not asked to do anything else other than find the minimum or maximum. And then what is that minimum or maximum? Okay. So first, we got the first question is y is equal to 2x squared minus 4x plus 5. What form is that? Standard or vertex? Standard form. So let's think about it a little bit. If we have something in standard form, that means we can list the A, B, and C, because that's going to tell you if it goes up or down, right? My A value is 2. My B value is negative 4, and my C value is 5. So does this go up or down? Up. It goes up because my A value is 2. So is 2 a minimum or maximum graph? Minimum. Okay, so we know this is minimum. But we have to find the value. So in order to find the value, what do I have to find? I have to find the axis of symmetry. And then I have to plug that in to find the vertex, right? Because ultimately, we need this vertex. We need that y value at the vertex in order to find what that minimum is. So we have to find the vertex. So we have to do the x equals negative b over 2a. So the opposite of negative 4 is 4. 2 times 2 is 4. So my x value at the vertex is 1. Now we plug it in to our original equation. 2 times 1 squared minus 4 times 1 plus 5. 1 squared is 1, so that's 2. 2 minus 4 plus 5. 3. So my vertex is at 1, 3. That makes this minimum value 3. So it may just be asking you for the maximum or minimum, but in order to do this, you have to find the vertex. That means you have to find the axis of symmetry if it's in standard form. Okay. See if you can find it for that one. State whether it's a minimum or a maximum, and then find it. State if it's a minimum or maximum, and then find it. Missed a foot away. Sad. It's a hard knot for us. What is that from, Annie? Yep. Why Annie would get popped into my head? I know I make a good door. Problem is the door gets wider and wider and wider. It's in standard form. So a equals negative 3, b equals negative 18, c, which we really don't need, but for fun, negative 7. So my a value is negative. So this is going to be a maximum point. X is equal to the opposite of b over 2a. b is negative 18. Opposite of negative 18 is 18. 2 times negative 3, negative 6. So my x value at the vertex, or my axis of symmetry, is negative 3. Now we're going to plug that in. So that's negative 3 times negative 3 squared minus 18 times negative 3 minus 7. So order of operations. Negative 3 times negative 3, because we have to square negative 3. That's 9. So that's negative 27 plus 54. Yeah. Yep. Minus 7. So that's 20. Yes? Did we get 20? Yes? 20? So that's my y value. So this is a maximum at 20. Boom, boom, boom. Can we find the maximum or minimum? It's about finding the axis of symmetry. It's good practice to continue to find the axis of symmetry. Next thing we have to look at then is we have to look at word problems. I'm going to sneeze. Told you. Thank you. So word problems means we read through them and then we kind of figure out what we know. It says a rocket carrying fireworks is launched from a hill 60 feet above the lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by the function h of t is equal to negative 2t squared, so there's our equation, plus 32t plus 60. Okay, so we've got this lake down here, and we've got this cliff. This person standing up here, he shoots off this rocket, and it goes like this. Okay, and this is the ground. Okay, this is the maximum height that this rocket is going to reach. Okay, so we have a parabola that's formed here. Now it says we're initially 60 feet above the lake. Okay, that plays into it. And if you notice in our equation, that plus 60, that's in reference to how far we are above the lake at the start. That's what that refers to. T is equal to time in seconds. And that's important. The h is equal to the height. So when you see the h, that's the height. The t is time in seconds. So the first question says, what is the height of the rocket after 2 seconds? Okay, so we know the t value. The t value is 2. So for this question, our height is going to equal negative 2 times 2 squared plus 32 times 2 plus 60. It really has nothing to do with what we've been doing other than evaluating functions. The t value is what's given to us. We just need to plug it in. So now we solve. So that's negative 2 times 4, which is negative 8. 32 times 2, 64? Yep. Plus 60. Does somebody with a calculator add that up for us? 124 minus 8, 116. Okay, so after 2 seconds, it's traveling at 116 feet. The next question says, what is the height of the rocket after 4.5 seconds? Well, now instead of using 2, we use 4.5. Help. Yeah, this one I can't do in my head. That's where we break out the trusted dusty calculator. So negative 2 parentheses 4.5 squared plus 32 times 4.5 plus 60. 163.5? Okay. So that's 163.5 feet. Do I know if I've reached my maximum height yet? Nope. So we can agree that that's the maximum height, right? That's the vertex. So if I want to find its maximum height, first we have to find the axis of symmetry. X is equal to negative b over 2a. Okay, so what's my a value? What's my b value? 32. So that's negative 32 over 2 times negative 2. My a value is negative 2. 2 times negative is negative 4. So that equals 8. So this is telling me right here that after 8 seconds, it's going to reach its maximum height. Because think about what this is doing. It's going like this. It's reaching its height at the vertex. So we've got that vertex. So that means at 8 seconds, it's reaching its maximum height. How do you suppose then we go about finding its maximum height? What do I have to do with that 8? Plug it in. So my maximum height is going to be -2 times 8 seconds plus 32 times 8 seconds plus 60. Again, another calculator question. $188. So the maximum height of this above the water is 188 feet. These all come about by understanding what the different things mean and the importance of what does T represent. In this case, the T represents the time in seconds. So we can just go ahead and if we're finding the height, just plug those things in. Then understanding if we want to find its maximum height, I have to find the vertex. That vertex is going to give me how long it takes to get to its maximum height and the height of that at that point. Questions with that one?